Hi friends, in continuation with respect to the previous video, with respect to binomial distribution, now we shall learn how to find the variance and standard deviation of the binomial distribution. In this, we shall make some substitutions in order to simplify the method of calculating the variance. We know that variance is denoted by sigma x squared or VAR of x, where of x, which signifies variance. This is given by expected value of x squared minus expected value of x the whole square. That is expected value of x squared minus mean the whole square. So what mean we have calculated here? NP. That would be we would be using at the end in order to find the variance. And now in order to find this, I shall in order to find the expected value of x squared, I shall do some variation here. Add and subtract x in the value in the e of x squared, that is within the e operator, within the expectation operator, add and subtract capital X. So x squared minus x plus x within e I am doing. So e of x squared minus x plus x minus e of x the whole square. This remains as it is. Now take capital X as the common factor between the first and the two terms in the first expectation term. So I get e into x squared minus x. That is, if I am considering x squared minus x as one term and e of x and this x as another term. Within e, what I have done is I have added and subtract x here. So x squared minus x plus x within e I have. Now consider the first and the second term. So that's why I am including x squared minus x within one bracket. So e of x squared minus x within one bracket plus x minus e of x the whole square. Now apply the one standard formula, apply the linearity property of the variance. So expected value of two variables is equal to the sum of the expectation of two variables. Apply the properties of the variance and apply the property of expectation also. The expected value of the sum of two variables is equal to the sum of the expectation of two variables. Let me repeat. One of the most important properties of expectation is that the expectation of a sum of two random variables is equal to the sum of the expectation of the two random variables. This is called the linearity property of the random variables. I mean to say, suppose I have got two random variables a and b, then expectation value of a plus b is equal to e of a plus e of b. So here a is x squared minus x, b is x. So that's why this would be equal to e of a plus b equal to e of a plus e of b, where a is x squared minus x, b is x. So that's why I have e of x squared minus x plus e of x minus mean the whole square. Now x squared minus x, take capital X to be the common factor. So capital X into x minus 1. So expected value of x into x minus 1 I have plus e of x minus e of x the whole square. Now my task is cut out in evaluating expected value of x into x minus 1, which is what we are going to do now. Now expected value of x into x minus 1 is simply given by summation x is equal to 0 to n x into x minus 1 into px of x. Expected value of x into x minus 1 is given by summation x is equal to 0 to n. So what x into x minus 1 I have in capital letters, put that x in small letters in inside the summation. Within the expectation operator, it is a random variable, that is capital X into x minus 1. When I am doing the mathematical simplification, that small x into x minus 1 gets replaced by x into x minus 1. That's how we do it in practice. So summation x is equal to 0 to n x into x minus 1 into px of x. So px of x is the nothing but the binomial distribution PMF. So that's what I have substituted here. NCx p to the power of x into 1 minus p whole to the power of n minus x. Or instead of 1 minus p, I can put q to the power of n minus x also. That's also allowed. Now, substitute for NCx. We know that NCx is given by factorial n divided by factorial n minus x into factorial x. I have only substituted for NCx. So this is equal to factorial n by factorial x into factorial n minus x. Now, we are going to do a very, very important expansion here. Now, let me put x is equal to 0. Now, if I want to expand this summation, this would be 0 into 0 minus 1 into this term plus 1 into 1 minus 1 into this term. So 0 into any term is 0. So there is the zeroth component, the zeroth expansion gives me 0 only, plus 1 into 1 minus 1. 1 minus 1 is 0. So 0 into anything is again 0. 0 into 1 is 0. 0 into this full term is also 0. So that's why 0 plus 0 plus summation x is equal to 2. I have expanded 0. I have put x is equal to 1. After 1, I have got the next integer, that is x is equal to 2. So it would be summation x is equal to 2 to n. So again, x into x minus 1 into this factorial into this 2 powers. That's what I have written here. So what I mean to say is, by writing x is equal to 0 to n in the summation, 2x is equal to 2 to n in this summation, I mean that there is no contribution from the x is equal to 0 value and x is equal to 1 value, because they give 0. So that's why this summation from x is equal to 0 to n reduces to summation x is equal to 2 to n. Very, very important observation. Okay. So there is, since the 0th value, x is equal to 0th value gives the amplitude value of 0, and since x is equal to 1 value gives a value of 0, that's why the summation from x is equal to 0 to n reduces to a summation x is equal to 2 to n. Now look what I am going to do. I have got x into x minus 1 divided by factorial x. So I shall use one substitution for use the formula that I had discussed in the first video corresponding to binomial distribution. X into x minus 1 by factorial. Now let me evaluate this. X into x minus 1 by factorial x. X into x minus 1 by factorial x. This I shall evaluate. So that's what I have written here. X into x minus 1 by factorial x. Now x numerator, let me keep it as it is. X into x minus 1, I am going to keep it as it is. Factorial x can be written as x factorial of x minus 1, based upon the argument that we did in the first video when I started with binomial distribution. So factorial x can be written as x into factorial x minus 1. Now x and x gets cancelled. I am left with x minus 1 by x minus 1 factorial. Now again apply the same recursive formula. X minus 1 by x minus 1 factorial I get, because x and x gets cancelled. Now x minus 1 factorial can be written as x minus 1 into factorial of x minus 1 minus 1. That is, I get x minus 1 by x minus 1 into factorial of x minus 2. X minus 1 gets cancelled, and I am left with 1 by x minus 2. So here one should be very, very careful, right? That's what I told. I am evaluating x into x minus 1 by factorial x. So x into x minus 1 by factorial can be written like this. Factorial x can be written as x into x minus 1 factorial. So x and x gets cancelled. I am left with x minus 1 by x minus 1 factorial. Now x minus 1 I shall keep it as it is in the numerator. Now in the denominator, x minus 1 factorial can be written as x minus 1 into x minus 1 minus 1 factorial. That gives me x minus 2 factorial multiplied by x minus 1 in the denominator. That x minus 1 and the numerator x minus 1 gets cancelled out, and I am left with 1 by x minus 2 factorial. So this is my 1 by x minus 2 factorial, which I have written here. After this step follows due to the application of this. So I get factorial n by x minus 2 factorial. So this 1 by x minus 2 factorial is incorporated here. So 1 by x minus 2 factorial into factorial n by n minus x is factorial n by x minus 2 factorial into n minus x factorial with these powers. I hope it is very clear. 1 by x minus 2 factorial is multiplied with this and combined into a common fraction. Now please note what I am going to do in the next step. I shall put this p to the power of x can be written as p to the power of x minus 2 plus 2. For brevity purpose, brevity and for simplification purpose, I am going to do this addition. See what I am going to do. P to the power of x, I am writing as add and subtract 2 in the power corresponding to p. So p to the power of x minus 2 plus 2 I am having. So p to the power of x minus 2 separately I shall take it, p squared I shall separately take it. For simplification purpose I am doing. So ಅದನ್ನ ಇಲ್ಲಿ ತೋರಿಸಿರೋದು ನಾನು ನಾವು ಮಾಡಿರೋದು. ಇವಾಗ ಇಲ್ಲಿ n into n minus 1 ಹೇಗೆ ಬಂತು, p squared ಹೇಗೆ ಬಂತು ಅಂತ ನೀವು ಕೇಳಬಹುದು, right? So p to the power of x is nothing but p to the power of x minus 2 plus 2. P to the power of x I have here. Now this p to the power of x I am writing as p to the power of x minus 2 plus 2. I am adding and subtracting 2 in the power corresponding to p. Corresponding to p ಅಂದ್ರೆ ಪವರ್ ಯಾವುದು? ಪವರ್ಗೆ ಇರೋದು p ಇದ್ದಾನೆ. p to the power of x ಇದೆ, ಅದನ್ನ add and subtract 2. So I get p to the power of x minus 2 plus 2. These are all mathematical steps which are needed for substitution, simplification. Then you may ask, sir, from n factorial n, how did I get n minus 2? Now I shall apply that formula again. Factorial n can be written as n into factorial n minus 1. This can be written as, apply the formula again, n into n minus 1 factorial of n minus 2. So that's what I have got here. See, 2 steps at a stage I have written. ಒಂದೇ ಬಾಣದಿಂದ ಎರಡು ಹಕ್ಕಿಗಳನ್ನ ಹೊಡೆಯೋದು ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಒಂದು ಕನ್ನಡದ ನಾನ್ ನೋಡಿ ಗಾದೆ ಮಾತಿದೆಯಲ್ಲ, ಅದೇ ತರ ಇಲ್ಲಿ ಮಾಡ್ಕೊಂಡಿರೋದು. p to the power of x can be written as p to the power of x minus 2 plus 2, wherein I have added and subtract 2 here. Now factorial n, which I have here in the numerator, factorial n I am writing as n into factorial of n minus 1. That can be written as n into n minus 1 into factorial of n minus 2. Repeatedly, recursively applying this procedure. So that's what I have here. Factorial n written as n into n minus 1 into factorial n minus 2. But n into n minus 1 is a constant because the summation is with respect to x. So n into n minus 1 is a constant. So this n into n minus 1, I can take it outside. When writing factorial n can be written as n into n minus 1 into factorial n minus 2. But n into n minus 1 is a constant. So instead of writing inside, I am taking it outside here. So n into n minus 1 into, next, p to the power of x is equal to p to the power of x minus 2 plus 2 antide alva. So this I am writing as p to the power of x minus 2 separately. So p to the power of x minus 2, I am separately keeping it inside the summation because x variable is there and summation is a variable of x. Whereas p squared is constant, so that also I am taking it outside. So this is how I am doing the manipulation. So very important step. Normally students make mistake here, so that's why I am stressing on this point. ನೀವು ಡಿರೈವ್ ಮಾಡುವಾಗ ಇದ್ರ ಮೇಲೆ ತುಂಬಾ ಸ್ಟ್ರೆಸ್ ಮಾಡಬೇಕು. ಸೊ n into n minus 1 into p squared. ಸೊ p squared, ಈ p squared ಇಲ್ಲಿ ತಗೊಂಡಿದ್ದೀನಿ. p to the power of x minus 2 ಇಲ್ಲೇ ಇಟ್ಟಿದ್ದೀನಿ. 1 minus p to the power of n minus x ಹಾಗೆ ಇರುತ್ತೆ. Okay, next I am putting y is equal to x minus 2 here. I am putting y is equal to x minus 2 here. I am putting, hello itadu, put y is equal to x minus 2. Put y is equal to x minus 2. Okay, and in the same case ನಾವೇನು ಹಿಂದೆ ಏನು ಮಾಡಿದ್ವೋ I am also putting m is equal to n minus 2 and I am putting m is equal to n minus 2. So I am doing two substitutions at the same time. I am putting y is equal to x minus 2 and m is equal to n minus 2. Now n can be written as m plus 2. N can be written as m plus 2. And when x is equal to, now do the summation changes. I am putting y is equal to x minus 2 and m is equal to n minus 2, right? So this n minus 2 factorial gets replaced by m factorial here. Please observe here. I am putting y is equal to x minus 2 and also m is equal to n minus 2. There would be variable changes with respect to y because y is dependent upon x here because summation is with respect to x. M is equal to n minus 2 means this n minus 2 factorial gets replaced by m factorial here because of the virtue of the summation, because of the virtue of the substitution. Since I have put m is equal to n minus 2 along with y is equal to x minus 2, so m is equal to n minus 2 means n minus 2 factorial gets replaced by m factorial. Also, n can be written as m plus 2. N can be written as m plus 2, and put the value, and x can be written as y plus 2. So doing so, y and minus y gets cancelled. 2 and minus 2 gets cancelled. 2 and minus 2 gets cancelled, and I am left with m minus y factorial for n minus